Hello, my lovelies! It's Susanne, and today I want to show you how to solve this equation in the real number system. This equation was part of an exam at university, so not that easy to solve. We have x here in the exponent and also here in the exponent, so we have an exponential equation. And every time we're dealing with an exponential equation, we have to use the logarithm at one point to solve for x. The question is, when shall we do that? Would it be a wise idea to do it at the beginning? Well, let's see what happens if we use the logarithm now. So we take the logarithm on the left side, so we put the complete left side in the logarithm here, and the same on the right side. We take the logarithm of the whole right side, which is only the 130. Now, on the left side, we have a sum in our logarithm, and there is no rule how to deal with this. There is no possibility to get the x out of this logarithm now, so we made everything worse. So taking the logarithm at the beginning is not a good idea. So what else can we do? Well, we could take a look at the numbers here. So we have base 2 and base 8, and there is a connection between these two numbers. We can write the 8 as 2 times 2 times 2, right? So 8 is the same as 2 to the power of 3. So let's write the 8 like this. We take the 2 to the power of x, we don't change this, but instead of the 8, we write 2 to the power of 3 and then to the power of x. So we put parentheses here and to the power of x, and on the other side we have the 130. Okay, so we have 2 to the power of x here and 2 to the power of x somehow here as well. Not really 100% because it is separated by this 3 here, but let's write it a bit different. We take our 2 to the power of x, and then here we are allowed to switch these exponents. We can write 2 to the power of x first, and then to the power of 3. Why is that? Well, let's see. Let's take this. So we have 2 to the power of 3 and then to the power of x. The rule is that if you have this structure here, you take your base and you multiply these two exponents. So 3 times x. But that's the same as switching these two. 3 times x is the same as x times 3. That's just a multiplication. And then if you want to write it with these parentheses again, you have your base, and now you have to the power of x first, and then you put the parentheses, and then to the power of 3. So this is the same. You can always just switch the exponents. And this is what we did here. So everything is correct, what we did. And on the other side, we have our 130. So now we have the 2 to the power of x here and also here. So we have a beautiful equation. It doesn't look like it, but trust me, it is, because this 2 to the power of x repeats itself, and we can use substitution to solve this equation. Because at the moment, the equation is too complicated to solve. We don't know how to do it, right? But we can make it simpler by substituting the thing that makes it difficult, and this is the 2 to the power of x, which repeats itself. So instead of this green thing, from now on, we call it different. We don't write 2 to the power of x, we just say we call it y. Just pick any variable you like. You can take z, u, v, whatever you like. We pick y here, and instead of the 2 to the power of x, from now on we write y. This is a common way of solving equations that are a bit more difficult, but that have a structure, so things that repeat itself. So what would we have then? Instead of the 2 to the power of x, we decided to call it y from now on. So we have y plus, instead of 2 to the power of x, we write y here, and then to the power of 3. And on the other side, we have our 130. This is a much simpler equation now. This is just a polynomial equation, not an exponential equation anymore. So the plan is we solve this equation for y, get results. We have to find them, but that's the plan for now. We solve this equation for y. If we have our results, then we go back to our substitution and find our results for x, for our original equation. So we have a lot to do. Let's see how to solve this equation now for y. So a new problem. Okay, we have y to the power of 3 in here. So a polynomial equation, we put everything on one side. So we subtract 130 on both sides. What do we get then? Here we have the y plus y to the power of 3. We subtract the 130, and on the other side, this cancels out, and we get 0. On the left side, I would like to rearrange the terms a little bit, starting with the y to the power of 3. So I would switch these two so that we start with the y to the power of 3, then we have the y part, and then the constant equals 0. I wrote down this equation here again, and now we have to find the roots of this equation. How? We have y to the power of 3, so it's not so easy to find all the roots here, but we could use synthetic division to find all of them. For that, we have to guess our first root. It's not a joke, that's the official way how to solve such equations. We have to guess the first root. But because this was an equation of an exam, the roots are not that complicated. So we test plus and minus 1. Then we check if plus and minus 2 is a root, or plus and minus 3, and so on. And let's hope that one of these numbers is a root of this equation. So we start with plus 1. We put it in here for our y and see if 1 solves this equation. If it does, we found a root. If it doesn't, we go on with -1. But there is something else that helps us, that we don't have to check all the numbers. And this is the so-called rational root theorem that says that if your roots are rational numbers, then they have to be divisors of this constant here. So this number that doesn't have a y, here, this part, that's the 130. We now check, is the 1 a divisor of 130? Yes, it is. So we have to check these two numbers, plus and -1. Same here. Is the 2 a divisor of the 130? Yes, it is. So we have to check this number. What about the 3? The 3 is not a divisor of 130, so we don't have to check the 3. Same with the 4. 130 is not divisible by 4, so we don't have to check these numbers. 5 is a divisor again, so we have to check this. But well, it's better than nothing. So let's start by checking if plus 1 is a root of this equation. So we put the 1 in here for the y. So we have 1 to the power of 3 plus 1 minus 130, and let's see if this equals 0. 1 to the power of 3 equals 1, so we have 1 plus 1 minus 130. No, this is not 0. Okay, so the plus 1 is not, the plus 1 is not a root. What about the -1? So we put the -1 in our y, put it to the power of 3, then plus -1, and we subtract 130 and see if this equals 0. But here also these numbers are too small. This minus 130 is way too large. It's not going to be 0, so the -1 doesn't work as well. So let's go on here with the plus 2. We put the 2 in for our y, so we have 2 to the power of 3 plus 2, and we subtract 130, but also here 2 to the power of 3 is just 8. This is not 0, so the plus 2 doesn't work, and the same with the -2. If we put it in here for our y, these numbers are too small. The minus 130 destroys everything. So here we have negative 8 then, but it's not going to be 0. So also the negative 2 doesn't work. So let's see if the plus 5 helps us now to find our root. We put the 5 in here. We have 5 to the power of 3 plus 5. The numbers are getting larger, and we subtract 130. 5 to the power of 3, so 5 times 5 times 5 equals 125 plus 5 equals 130 minus 130 equals 0. So the plus 5 is our root we were searching for, our first root we had to find. We got it now, so I write it down here. Y equals 5 is a solution to this equation here. And now we have to find more solutions. Because of this to the power of 3, we can find 3 solutions to this equation here. It can be real roots or complex roots. We only need the real roots, by the way. That's what we had to find. But maybe there are some. So we use this 5 we just found to find the other roots. We wanted to use the synthetic division, so for that we take our root, so the 5, and write it like this, just highlight it like this. And then we write some numbers in a table. We have to use the coefficients here of our polynomial, so it starts with y to the power of 3, then such a polynomial can have a part with y to the power of 2, then a part with y, and then a part without any y, so a constant. What is the number in front of the y to the power of 3? Well, we can't see a number here, then it is a 1. So we put a 1 in our table here. What is the number in front of the y squared? There is no y squared at all in here, so there is a 0 in front of that, so that it disappears. What is the number in front of the y? Here we have a plus 1 times y, so 1 is the number. And our constant, that's here the negative 130, we put it in here. This is our table. I erase this again. This was just for us to help a little bit. Now, we leave a little bit of space here. And now it starts as follows. We drop down this number here, so the 1 goes down here. And now we multiply this 1 by this red number, so by our root. So we multiply it by 5, so 1 times 5 equals 5. Now we add these two numbers here. 0 plus 5 equals 5. We do the same again. We multiply by our red number by 5. 5 times 5 equals 25. And we add these two numbers, which equals 26. And one last time, we multiply by 5. 26 times 5 equals 130. And we add these two, and this is perfect that this adds to 0. So this is our remainder. Everything is good. If you have a 0 there, then you know that this was really a root of your equation. The 0 here is not important, but we need the numbers here because we wanted to find more roots. Remember? That was why we do all of this. But for finding new roots, we need a new polynomial. We need a new equation to solve. And these numbers help us with that now. We had y to the power 3 to begin with. So our new polynomial, we have to decrease the exponent by 1. So we start with y to the power of 2 now. Then in a polynomial, we have a part with y. And then here is going to be a constant number. And these numbers here are now the coefficients. So the 1 goes in front of our first part, the 5 goes in front of our second part, and the 26 is our constant number. And this is our new polynomial we're going to work with. We just set it to 0 and search for more roots. 1 times y squared, we can only write y squared like this. And now let's see how to solve this equation. We keep in mind that we already found a root, so this is already a solution we found, but maybe there are more real roots in here. We have a quadratic equation here. We can check if the numbers here are easy enough to use factorization to solve this equation, but 26 and 5, these are not easy numbers. So just take the quadratic formula to solve this equation. I write it down again. It looks like this. We have minus b plus minus the square root of b squared minus 4ac divided by 2a. What is my a here? What is my b? And what is my c? A is the number in front of my y squared. There is no number we can see, so it is a 1 times. So my a equals 1. My b is the number in front of the y. It's the 5. And my c is the number that has no y at all. It's the 26. And let's just put everything into our equation here. Minus b equals 5 plus minus the square root of b squared, so 5 squared, minus 4 times 1 times 26 and divided by 2 times 1. Let's calculate the square root here. So we have 5 squared equals 25, and we subtract 4 times 1 times 26 equals 104. So the result here would be negative in our square root. So we are done here because we were only searching for real solutions. And a negative number in a square root is a complex solution. So we are done here with this equation. We don't find any more solutions. The only solution we have is our 5. So we take it, go back to the beginning. Do you remember what we were doing? We were searching for solutions for our simple equation here. We now got one. This is the only real solution that exists to this equation. Now we take this solution here back to our substitution because we want to find the solutions for our original equation. So for our y, we put in our solution we found. It's the 5. And this equals 2 to the power of x. And now this is the only thing we have to do. Solve this simple exponential equation for x. X is an exponent, so we use the logarithm on both sides. We have the logarithm of the left side, so of 5 equals the logarithm of the right side, so of 2 to the power of x. X is here as an exponent in our logarithm, so there is this rule that we are allowed to move this x in front of our logarithm. We leave the left side as it is, but on the right side we take our x out of the logarithm and multiply this by the rest, so by the logarithm of just the 2. Now, if we want to solve this equation for x, we just have to get rid of the log of 2, so we divide both sides by log of 2, and then we have our results. This is our result, so this beautiful number we get here, you can always use the calculator to calculate this, but this is the exact solution, and this equals just x because the logarithm here cancels out, and this is our solution for our beautiful equation here. Wow, I hope you're still with me. That was a lot. If you have any questions, please let me know in the comments. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care.